Okay, so the next part, it says part of the graph of the cubic and the following. So we have two unknowns, P and Q, and we're told that P and Q are elements of Z. So they're positive and negative, but they're whole numbers. And X is an element of the real numbers, is shown below not to scale. It cuts the axis at a half and the y-axis at 0.6. Find the value of P and Q. Okay, so y is equal to 2x cubed plus px squared minus 11x plus q. Here again, we have this whole thing of it cuts the y-axis at 0.6. So if x is 0, y is supposed to be 6. So they're all zeros, 0, 0, 0, 0. So the only thing I'm left with is q. So I straight away know q is 6. Now, if I know that q is 6, then I can rewrite it here, putting in the value of q to be 6. Now, I also know that it crosses the x-axis at a half. So if y is 0, x should be a half. So I'm just using that junior cert concept here, that if the x is a half, then y is 0. So I plug all of this into my calculator and it comes out with, actually I might have worked bits of that out. I will show you here because, so that's going to be an 1/8. This is going to be a quarter. And this is going to be minus 11 over 2, and this is going to be 6. So if you tidy all of that up, well, that's going to be a quarter, 2/8. That's going to be p over 4. This is 11 over 2, and this is technically 6 over 1. So if my common denominator is 4, that's 1 plus p minus 22 plus 24. And then that's 0 over 1. So I have, what's that? 2 and 1, that's 3. So it's 3 plus p over 4 is equal to 0 over 1. And if I cross multiply, I get 0 is equal to 3 plus p. So p is minus 3. Okay, and that's it. And I gave 10 marks for that one. The next one, x is a positive real number with the following. Now, this is identical actually to a one we did in class. So I really thought, in fact, I hesitated to put it into the test because I thought maybe it's too like the one we did in class, too easy, but it proves it wasn't. So the first thing I noticed is all the bases are different. That's not good. Okay, I don't want that to happen. But, and then the second thing I think is ones. Well, where would a 1 have come from? So what I do in each case is, instead of the 1, I do log of 2 to the base 2 over log of x to the base 2. Now, for the next one, because the base is 4 in this one, then instead of 1, I do the log of 4 to the base 4, if that makes sense. Because the base is 8 in the next one, I do the log of 8 to the base 8. So if I have matching log and base, I have 1. Now, you might be wondering, why am I doing this? Well, I'll explain now in a second. So I'm just picking basically whatever the base was in the denominator, I am making them match in the numerator. Now, if you look at this formula here, you'll notice that you can do this formula in reverse. Normally we go here and we change the base, but it also works in reverse. If you have 2 logs, and so if you have 2 logs and 2 matching bases, the b is in this part here and the a is in this part here. So that's essentially what I'm going to do. So I'm going to write log. Now my b is my 2, so 2 goes there. And my a is my x, is the bottom number basically. So that x is my a. Now what you'll notice is, as I work my way along the line, again, I have matching log and base. They're both at log, they're both 4. So all I do is I reverse the process, and whatever's on top, 4, and my old base, well, that would have been x. So I'm just hitting the reverse here, really. So I do exactly the same here, matching log and base. So that ends up becoming 8. And I do the exact same here. I reverse the process. That's my base and that's my number. So and that's equals to 5. Now, if I have addition of logs, that's the same thing as multiplying, because now they all have the same base. So I multiply 2 by 4 by 8 by 16 equals to 5. When I multiply all of these together, I end up getting 1024. Now, to extract the x there, I go from logs to indices. That's how I get that x out of that position. I do the snail. So I do x to the power 5 is equal to 1024. And how do I get rid of the power 5? Well, I do the fifth root of 1024. And the answer is 4. And that was 10 marks. So go back and have a look at the one we did in class, or maybe you did it in homework. I'm trying to think now. No, I think we might have done it in class. We definitely did something like it anyway. This next one down here was also worth 10 marks. This was a much easier one. All you had to do here was identical to the ones you were doing for homework. I brought the logs to the same side first. Equals 3. Because the logs have the same base, I can use my rule of logs, which tells me if they're being added, I can multiply them. So I'll just tidy that up. So that's x squared minus 2x. Now, how do I, there's a log here and I want to get into that x, so I do my snail on it. So 2 to the power 3 is equal to x squared minus 2x. Now, 2 to the power 3 is the same thing as me saying 8. So bringing it all to the one side. And then I basically solve. So I open up two brackets, x, minus, and a plus. So I have to have one of each sign, minus and plus. So it's going to be 4 and 2. So x is 4 and x is minus 2. Now, when I relate it back to the question, is it okay for me to have a minus? Like on the left-hand side there, it's the log of x to the base 2. So if I try and put in a 4, that would be okay. But if I was to try and put in a minus 2, that would not be okay. So for that reason, the only acceptable answer is that x is 4. And that was, as I said, was worth 10 marks.